The goal of muscle tissue is to contract and generate force. So let's talk about what a twitch is and then how those add together or summate to create enough muscle tension to be able to do stuff like move. So this is called a myogram. A myogram is a graph of muscle tension. So muscle tension over time, and we are going to draw tension on the y-axis, so changes in tension over time. And I've already told you that a twitch is a single contraction relaxation cycle caused by a single action potential from the motor neuron causing a contraction in the muscle, shortening of sarcomeres. Relaxation occurs when calcium is pumped back into the SCR, which turns the muscles off, and there's no more acetylcholine to stimulate calcium release. It takes about 15 seconds to reach this maximum tension development, and then 40 seconds back down again. So that would be, again, a single muscle twitch. So I'm going to draw this for you here. Let's start with right here, time 0. So what's going to happen at time 0? We're going to call this where our stimulus happens. So the motor neuron that is stimulating the muscle. So before that, we've got the resting phase, right? The neuron is just at rest during this point. Actually, I want to remove that because I'm going to have the tension at rest is pretty much going to be 0. After we have the stimulus, there is a latent period. So we've got a couple of seconds actually before tension starts to be generated. This is called the latent period. So that is what's happening right here in between the stimulus and the beginning of the generation of muscle tension. So before the actual, I'm going to move this somewhere else. Before the generation of that muscle tension and therefore contraction. So here's time 0. I'm going to label in right here the stimulus. That latent period is from time 0 until the beginning of the contraction. So this is the latent period right here. After that, what's going to happen? We're going to have some contraction. We're going to have a contraction phase or contraction period. Muscle tension is going to go, I'm going to make it do a different color for this one. Muscle tension is going to go way up. This is our contraction phase. And this is what is close to 15-ish seconds. I'll put 15 here. Maximum tension due to one single action potential firing. I'll label that up here. That's going to be maximum tension development. And this whole thing we're drawing right here, right now, is a single twitch. After maximum tension development, after that contraction phase, what happens? Well, the calcium is pumped back into the sarcoplasmic reticulum and we have relaxation. So we've got, oops, I meant to do that a different color. Thought I changed it. There we go. Let's have relaxation. Relaxation phase or relaxation period. So this is going to be about 40 seconds. That's how long it takes for a single twitch. And you've probably felt these, right? When you have single twitches in your muscles, not usually consciously. This isn't normal muscle firing. So if we want to actually have movement, fluid movement, we have to either increase the frequency of action potentials. So instead of just one stimulus, having multiple, or we can increase the number of muscle fibers that are firing. So those are two ways to change the maximum tension that can be developed. So we'll get to both of those next. First, what I want to do is, actually, let's not do that yet. First, what I want to do is draw for you what that looks like, that summation of more than one twitch on a myogram. So there are different names, of course, for when you have more than one stimuli that do add together in time. So first of all, what we've got is a single twitch. I'm going to draw that again. So this is tension again on the y-axis. Start at 0. Let's say there's a stimulus. Actually, what I'm going to do is draw in blue down here an action potential. Remember, we can draw an action potential as a single blip. I will label that down here. This is action potentials. And then above that, I'm going to draw, let's not do that. So a single action potential, got it back now, is going to result in muscle tension, a single twitch that corresponds to a single action potential. It's a little bit wider because the action potential is happening much quicker. This probably isn't quite to scale. This is milliseconds, and this is going to be seconds that this occurs. This is, again, a single twitch. Then if we have multiple action potentials in time, we're going to start to add those together. So let me go back to my blue. First thing that can happen is if we have two action potentials that are not close enough in space, we can have what's called TREP. TREP means staircase. Let me draw one more action potential there. And it refers to the idea that although the twitches are still separate, there still is contraction occurring slightly higher than the previous one. So let me draw this here. This is going to look like this. So relaxation occurs completely each time, but it's slightly higher until we do still reach a maximum TREP. This is thought to be because there's a gradual increase in sarcoplasmic calcium, because not all of that calcium can be returned to the SER in between each relaxation. So this is called TREP here, staircase phenomenon, and it's thought to be due to the increase in calcium in this sarcoplasm that cannot be returned completely in between each of these fairly rapid separate twitches. This is not summation still. They're not being added together. It's just kind of an after effect. The next thing we have is going to be summation. So we're going to have action potentials that occur in time frequently enough for the muscle responses to start to be added together. So basically the second stimulus is going to occur before the relaxation phase ends. What this is going to look like is, let me get my fatter one here. Here we go. We've got a start to increase. It might start to relax. Before it completely relaxes, though, we've got a second stimulus. Maybe we've got the third stimulus there. Summation or wave summation. The muscle is already partly contracted when the second stimuli hits. So some calcium is already bound to troponin. When more binds, there's going to be even more contraction. It's a graded thing. There's levels to this. So the second contraction causes even more shortening than the first did. More shortening means more generation of force. This can occur even more. So this summation, basically everything from here out on this graph is going to be further types of summation. So I'm just going to actually start over here because I kind of got off here. If we have continued quick action potentials, so the nerve is firing multiple times, we will have, and those are actually a little bit close together. I'm going to do those a little bit farther apart. So this is going to be a type of summation that occurs here called unfused or incomplete tetanus. So tetanus is the, again, subsequent stimuli are occurring before relaxation can occur, but to the point where the maximum force in the muscle is generated. This is tetanus. So what this is going to look like is summation, 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 and we might be up here at the top, up and down like this. It's incomplete because we're still going up and down. That's in contrast to complete tetanus, which is going to be kind of maximum action potential frequency down here. And that's going to look like we got to increase, say we're starting from 0, and then boom, maximum muscle tension is generated. Relaxation phase is eliminated. No muscle relaxation can occur. This name is similar to what you've heard of for lockjaw tetanus. It's just complete contraction without relaxation. However, when this happens, this can happen without the toxin inducing it. So this summation is what allows for us to actually have coordinated muscle movements. Okay, let's do this on a different picture and do it as a learning check here. So if you could label each of these as best you can. This one I have partially labeled. Okay, this one's also labeled already. So this is TREP here. You can see that these individual separate twitches are still separate, but there's a staircase phenomenon happening here as the calcium inside this cell increases. Wave summation, this area underneath here, but we don't go back down to 0. That's what's key about this. Incomplete tetanus is a type of wave summation where we're reaching maximum up here, up and down. Then lastly, complete tetanus, we have no relaxation phase. We're just in contraction, maximal contraction. Okay, so what we've just done is interpret a myogram of twitch contraction with respect to the duration of those different phases that we just talked about, latent contraction and relaxation phases. Then we also interpreted a myogram of tension versus stimulus frequency. So stimulus frequency being the difference here opposed to just one single stimulus. And then the basis for TREP, summation, and tetanus, both incomplete and complete tetanus, which is the same basis for that. All this is going to be related to calcium, either not being able to be pumped back into the SCR completely or at all in between individual contractions.